A scoping review is a type of literature review that uses a systematic process to search for, collect, organize, and summarize all the available research on a broad topic. Please note that I use the word broad here because it is one of the main characteristics of a scoping review. Broad means covering a wide area or many aspects of a topic rather than focusing on one specific part. For example, what is known about the use of artificial intelligence in healthcare is a broad research question because it includes many applications, populations, and settings. A scoping review helps researchers understand what research already exists, what topics have been studied, what types of evidence are available, and where important research gaps still exist. Unlike other reviews that try to answer one specific research question, a scoping review focuses on exploring the available evidence. Instead of asking, "Does this treatment work?" it asks questions such as, "What research has been published on this topic? What populations have been studied? What interventions or methods have researchers used? Which countries or settings have been studied? What areas still need more research?" The final result is not a single answer or recommendation. Instead, it provides a clear overview of the current research landscape. When should you use a scoping review? The first situation is when the topic is exploratory. For example, if a researcher wants to conduct a scoping review on digital health technologies for managing diabetes, the review can include studies on mobile apps, wearable devices, telemedicine, remote monitoring, and artificial intelligence to show everything that has been studied in this area. A scoping review is also useful when the topic is new or rapidly developing. The purpose is to organize the available evidence when research is still growing and changing. For example, a scoping review on the use of generative AI tools such as ChatGPT in higher education can summarize how these tools are being used for teaching, learning, assessment, and research because new studies continue to be published every month. Another reason is when key concepts or definitions are unclear or used differently across studies. The purpose is to understand how researchers define and describe the same concept. For example, a scoping review on digital literacy among university students can find that different studies use different definitions and measurement methods. A scoping review is also appropriate when researchers want to map different types of evidence. The purpose is to bring together all relevant evidence, even if the studies use different research methods. For example, a scoping review on mental health support for healthcare workers can include qualitative interviews, quantitative surveys, mixed method studies, government reports, and policy documents to provide a complete overview of the topic. Researchers also conduct scoping reviews to identify research gaps. The purpose is to discover areas where evidence is limited or missing so future research can focus on those topics. For example, a scoping review on telehealth for older adults can find many studies from high-income countries but very few from low- and middle-income countries, showing an important gap in the literature. When should you not use a scoping review? A scoping review is not suitable when the goal is to answer a specific research question or determine whether an intervention is effective. In these situations, a systematic review is usually the better choice because it critically evaluates the quality of the evidence. For example, if the research question is, "Does cognitive behavioral therapy reduce anxiety in adults compared with usual care?" the objective is to measure effectiveness and reach a reliable conclusion. This requires a systematic review rather than a scoping review. A scoping review should also not be used when researchers need to compare treatments, develop clinical guidelines, or make evidence-based recommendations. These decisions require a detailed assessment of study quality and risk of bias, which is not usually the purpose of a scoping review. And, if the research question is already very narrow and clearly defined, there is little need to first map the literature. For example, if the question focuses only on the effectiveness of one medication for treating migraine in adults, a systematic review is more appropriate because the objective is to evaluate the evidence rather than simply describe what research exists. Scoping review versus systematic review. Although both review methods follow a structured search process, they answer different types of research questions. A scoping review asks broad exploratory questions such as, "What research exists on this topic? What populations have been studied? What interventions have researchers examined? What research gaps remain?" Its goal is to explore and map the available evidence. A systematic review, however, answers one focus question, such as, "Does a specific intervention improve patient outcomes? Which treatment is more effective? What does the highest quality evidence show?" a systematic review evaluates the quality of each included study, assesses the risk of bias, and can even combine study results using a statistical method called meta-analysis when appropriate. One way to remember the difference is this: a scoping review explores the evidence, a systematic review evaluates the evidence. Steps to conduct a scoping review. These are the main steps used to conduct a scoping review. I have linked detailed videos in the description where you can learn how to complete most of these steps one by one. Step 1. Define the research question. Start by defining the purpose of your review and writing a clear research question. A common framework used at this stage is PCC, which stands for Population, Concept, and Context. See the video linked in the description to learn how to develop a research question using the PCC framework. Step 2. Develop a protocol. A protocol is a written plan that explains exactly how the scoping review will be conducted. It should include the review objectives, eligibility criteria, inclusion and exclusion criteria, databases to search strategy, study selection process, data extraction method, and how the findings will be summarized and reported. See the video linked in the description to learn how to develop a protocol. Step 3. Register the protocol. Many researchers register their protocols on the Open Science Framework. Step 4. Search the literature. Now search for relevant studies in appropriate databases. You can search for relevant articles using AI tools. Watch the linked video to learn how to do this and get the prompts. Step 5. Screen and select studies. Import all search results into a reference management tool, remove duplicate records, and screen the titles and abstracts. Next, review the full text of eligible studies using your predefined inclusion and exclusion criteria. This screening process is very similar to the one used in PRISMA. I have linked PRISMA's screening video in the description if you would like to see the title, abstract, and full text screening process step by step. Step 6. Extract data. Extract the required information from each included study using a standardized data extraction form. Common data items include the author and year, study design, population, concept or intervention, context, key findings, and important notes. I recently uploaded a video that shows how to extract data into a table format. You can find the link in the description. Step 7. Analyze and summarize the evidence. Organize the extracted data to identify common themes, patterns, and research gaps. Group studies by characteristics such as study design, population, intervention, or setting when appropriate. Step 8. Report the findings. Most reports include the following sections: introduction, methods, results, discussion, and conclusion. Report the review according to the PRISMA SCR reporting guideline to ensure the review is complete, transparent, and easy for readers to follow.